Hello friends, the topic for today is state space search in artificial intelligence or AI. Before an AI problem can be solved, it must be represented as a state space. A state space is then searched to find a solution to the problem. In this video, I will be covering the basic concepts and terms related to state space search, but here we are not covering a specific examples of AI problems. The agenda for today's video is review of basic concepts and terms, then state space search overview, then state space search notations, then search problem, representation of search problems, and searching process. So let us start with the review of basic concepts and terms. The first term is state. Each state is an abstract representation of the agent's environment. It is an abstract that denotes a configuration of the agent. We have already discussed the properties of task environments in the previous video. So there we have covered in details the different properties of the environment. Then the next term is state space. A state space is the set of all possible configurations or states of a system. It is useful abstraction for reasoning about behavior of a given system and is widely used in the field of artificial intelligence and game theory. A state space essentially consists of a set of nodes representing each state of the problem, arcs between the nodes representing the legal moves from one state to another, an initial state and a goal state. So each state space takes the form of a tree or a graph. So when we are solving the AI problems, then we can make use of either tree or graph and then proceed with the algorithms for solving those problems. Then let us go to the next, goal-based agents. Now again, we have already done a video on this. A goal-based agents further expand the capabilities of a model-based agents by using goal information. So goal information describes situations that are desirable. This allows the agent a way to choose among multiple possibilities, selecting the one which reaches a goal state. A goal-based agents need to achieve certain goals. Such an agent selects its action based on the goal it has. Then let us go to the next term, that is goal state. A goal state is a description of a set of desirable states of the world. A goal states are often specified by a goal test which any goal state must satisfy. The next term is problem formulation. The problem formulation means choosing a relevant set of states to consider and a feasible set of operators for moving from one state to another. Then next term is search. Search is the process of considering various possible sequences of operators or actions applied to the initial state and finding out a sequence which culminates in a goal state. So finally, our aim is to go to the goal state. So from initial state to goal state, there will be number of actions or operators. Then let us go to the state space search overview. Now when we are taking this overview, we'll have these steps. Formulate a problem as a state space search by showing the legal problem states, the legal operators, and the initial and goal states. A state is defined by the specification of the values of all attributes of interest in the world. Then an operator changes one state into another. It has a precondition which is the value of certain attributes prior to the application of the operator and a set of effects which are attributes altered by the operator. Then next, the initial state is where you start and the goal state is the partial description of the solution. That is the final state where you want to reach. Then let us go to the next, that is state space search notations. So here again let us begin by introducing certain terms related to this. The first term is the initial state. An initial state is the description of the starting configuration of the agent. That is the state where we start with the solution to the problem. Then next term is action. Action or an operator takes the agent from one state to another state, which is called as the successor state. A state can have a number of successor states. Then next term is goal test. The goal test which determines whether a given state is a goal state. Sometimes there is an explicit set of possible goal states and the state simply checks whether the given state is one of them. Sometimes the goal is specified by an abstract property rather than an explicit enumerated set of states. For example, in chess, the goal is to reach the state called checkmate, where the opponent's king is under attack and can't escape. So that is the checkmate. Then let us go to the next term, that is plan. Plan is a sequence of actions. So in the process, we take number of actions and plan represents the sequence of actions. The next term is path cost. The cost of a plan is referred to as the path cost. So the path cost is a positive number, and a common path cost may be the sum of the cost of the steps in the path. So as per the number of steps, the path cost will increase if the number of steps are more. Then next term is solution. A solution to a problem is an action sequence that leads from an initial state to the goal state. So the intermediate steps, they will be part of the solution. Then next is optimal solution. The solution quality is measured by the path cost function, and an optimal solution has the lowest path cost among all solutions. So it is just like the shortest path algorithm, where we have the shortest path. So here we consider the path cost instead of the shortness. Then the next we go to the search problem. We are now ready to formally describe a search problem. A search problem consists of the following. Yes, the full set of states, that is represented by yes. Then S0 is the initial state. Then A, that is actions. Now yes to S is a set of operators or actions. So here we are changing from one state to another, and all the states belong to the full set yes. Then G is the set of final state. Now these are represented schematically in figure 2. So here you can see we have the initial state and actions which will lead us to the goal state, and whole this oval is called as the state space. So state space will have all the states, initial state, then goal states, and the intermediates. The search problem is to find a sequence of actions which transforms the agent from initial state to the goal state. Now here G belongs to capital G. A search problem is represented by a 4 tuple, that means tuple with multiple elements, capital S, S0, A and G. So S is the set of states, S0 is the initial state which belongs to S, and then we have the actions or operators that transform one state to another state represented by A, and then we have the G, that is the goal state. So this sequence of action is called as a solution plan. It is the path from initial state to the goal state. A plan represented by P is a sequence of actions. So P is equal to A0, A1 and so on up to AN, which leads to traversing a number of states S0, S1 up to Sn plus 1, all belonging to G. A sequence of state is called a path, and the cost of path is a positive number, as we already discussed. In many cases, the path cost is computed by taking the sum of the costs of each action, that is the each step. Then let us go to the representation of search problems. A search problem is represented using a directed graph. The states are represented as nodes, and the allowed actions are represented as arcs. So we may get a graph, or even we can get a tree from that. Then searching process. The generic searching process can be very simple, described in terms of the following steps. Do until a solution is found or the state space is exhausted. That means all the states have been reached. So the first step is check the current state. Then second, execute allowable actions to find the successor state. Then third step, pick one of the new states. Then fourth step, check if the new state is a solution state or the goal state. If it is not, the new state becomes the current state and the process is repeated. So in this way, we are able to find the solution to the problem. So with this, we come to the end of this video. If you like the video, press the like button, share with your friends, and subscribe to our channel Engineering and Technology for You. And don't forget to press the bell icon to get notifications for our future videos. And thanks for watching. Have a nice day.